ওকে, সো আজকের এক্সপেরিমেন্ট কি কেউ সবাই জানো তো নাকি? বাকিরা, রোহিত ছাড়া বাকিরা? এনিওয়ান এলস? শুভদীপ ভট্টাচার্য? শুভদীপ,
ইয়েস স্যার।
এক্সপেরিমেন্টটা কি জানো তো নাকি?
হ্যাঁ স্যার।
সৌম্যদীপ বসাক, আছো তো সবাই?
Yes, sir.
ওকে, ঠিক আছে। So let's start the experiment. Okay. So is it visible to all? Okay. So let's start with our lab experiment class. Okay. So today's experiment number is 5, and the experiment name is Study and Calibration of Impulse Voltage Generator. Okay. So whenever we say impulse voltage, what picture comes to your mind? Impulse voltage.
So the voltage just for a momentary of time.
Yes, sir. A singularity function which will act as a, we can say at a time equals to 0, we will get a high amplitude over that instant.
Okay. That's what you are answering. It's like you are a second year student because you have already studied that step voltage, impulse voltage, etc. etc. That's different. But when we say impulse voltage, actually some other thing should have come in your mind actually. Where you can see the impulse voltage. You are a final year student, na? So you should explain.
So dielectric breakdown.
You can dielectric breakdown. Any other else?
So lightning.
Yeah. If you see the lightning, it's like it's an impulse voltage. Okay. Besides lightning, there are another impulse voltage. What is the name of that another impulse voltage?
So
Switching impulse.
Switching impulse voltage. Exactly. So lightning impulse voltage and switching impulse voltage. So whenever we say impulse voltage, how can we define an impulse voltage? Do you know that? You should say, because you have already studied your high voltage course in third year. So you should say, whenever we say impulse voltage, what is the parameter or defining parameter for impulse voltage? No one can tell me. Okay, there are two most important parameter. One is front time, another one is tail time. Can you remember the term front time and tail time? What is front time? Yeah, the time to reach the peak is front time, and the tail time certain percent, not certain, no, not certain percent, but the 50% of the peak voltage. Okay, at the after reaching the peak, Okay, so once the pulse actually has reached the peak, and after that, when the value actually reached the 50% of the peak, then the time from the starting is known as the tail time. Okay. Besides these two parameters, then there are another parameter which actually indicate the magnitude of the impulse voltage. Okay, that means we can say that 50 kilovolt impulse voltage. Okay, so these are the three primary parameters which are actually defining the impulse voltage. Now, if I ask you, what are the differences between switching impulse voltage and lightning impulse voltage? what is the parameter value of lightning impulse voltage and switching impulse voltage? How can you define a lightning impulse voltage? What is the value of front time of the lightning impulse voltage?
So around 1.2 microsecond.
Yeah, not around 1.2 microsecond and some tolerance band. And for tail time for the lightning impulse,
50 microsecond.
yes, 50 microsecond. And for switching impulse, front time,
200 to 250 microsecond.
250 microsecond, exactly 250 microsecond. And there are some definitely tolerance band. So if you say, yeah, considering tolerance band, 250 to 200 to 250 microsecond, that's fine. And your tail time,
So 2500 microsecond.
yeah, 2500 microsecond, 2500 microsecond. Good. So let's start the study and calibration of impulse voltage generator. Okay. So in our experiment, there are two primary objectives. First one is that to understand the circuitry of the 1400 kV, because in our laboratory, I think you have seen the impulse generator. Have you seen impulse generator? Because you have done some experiment in our laboratory. Is it? Oh, no. Any one of the experiment you have not done?
We have not been to the high voltage.
But have you visited the high voltage lab? Okay, so it is quite difficult to remember because at that time it is quite difficult. But when the lockdown was started, during the second year or third year? Second year. So during the second year, first semester, you have not visited the high voltage lab. Okay, no problem. Okay, I will show that figure. So in our laboratory, the impulse voltage, or I can say that if you after your course, when the lockdown will be over, then if you can come to our laboratory, you can see there is a very big impulse voltage. Okay, which is in the laboratory, actually middle of the laboratory, so you can easily see the higher impulse voltage. And if you ask me the rating of this impulse voltage, this is a 1400 kV. So you can imagine the voltage magnitude of this impulse voltage. So we can produce up to 1400 kV, and the energy rating is up to 16 kilojoule. Okay, so we have to understand the circuitry of 1400 kV and 16 kilojoule surge voltage generator or impulse voltage generator, because sometimes we say impulse voltage as a surge voltage. Okay, the high voltage laboratory. And the second one is that whenever you install a higher impulse voltage, not only just you have already installed the impulse voltage and that's all. That is not the thing actually. You have to calibrate, because there are certain what I can say, there are certain rules or there are certain norms. According to this, you have to calibrate the impulse voltage. Otherwise, according to the standard of different standard like IEEE, like IEC, you can't use that. So you have to calibrate the impulse generator according to the standards. Okay, and that calibration actually is done by spare gap, because this is a very standard spare gap. Okay, so have you seen that spare gap also in our laboratory? No, there is a too big spare, only in video. Okay. So let's start with that to understand the circuitry of the HV impulse generator. So before starting that, I would like to ask you, whenever you are asked to produce an impulse voltage, what is the basic circuit behind it? Not impulse. Suppose you are asked to generate a pulse. So if you are asked to generate a pulse, then which type of circuit you will use? Pulse means definitely there is some rise and there is some falls. Are you understanding? Because whenever I say pulse, that means there will be a rise and there will be some fall. So how can we generate this type of waveform? What type of circuitry we need to use for generating this type of waveform? Do you have any idea? Okay, let me explain. This is a very basic circuit. Okay, so whenever you want to generate a pulse, that means you require a capacitor and a resistor. Okay, So forget about this PR graph. Just consider this portion only. Okay. So suppose initially that capacitor there is no charge in the capacitor. Okay. So when that means initial condition of the capacitor is 0. Okay. So when the charge inside the capacitor is 0 and if you apply voltage, how the capacitor will behave? Can anyone tell me? Suppose there is no charge in the capacitor.
Like a short circuit.
Like a short circuit, exactly. That means when you apply voltage, that implies that there will be a flow of charging current, okay, and that will charge the capacitor. Is it clear? So when you apply DC, that means that VDC will charge the capacitor at a magnitude of V. Okay. Now, for the time being, consider this is a switch. Okay, that PR gap is a switch. Now, initially that switch was off. Now, once the capacitor is charged, now what you have done, you have actually closed the switch. Okay, then what will happen?
Discharging of capacitor happens.
Yeah, definitely the capacitor will start discharging through the resistor. Okay, and how long it will take to discharge completely, that will depend on the
Resistance.
Time constant.
not only resistance, you can say the multiplication of C and R.
Time constant.
Time constant. Okay. So that means if you record the charging characteristics and discharging characteristics of this capacitor through a CRO or any measuring instrument, okay, then you will see as it is a DC, and if we consider this is a pure capacitor, there is theoretically if we consider it is a pure capacitor, because in practical case the capacitor contains some resistance. Okay, so for the timing, for theoretically we can consider there is no resistance. So if you apply VDC, instantly the capacitor will be charged. So voltage will be reached instantly at a high value. Now once you close the switch, then what will happen? The capacitor will start discharging through this RE, and the voltage will start to be low. Okay, and how long, when the value will be 0, that depends on the value of capacitor as well as the value of resistance through which the capacitor is discharging. Is it clear? Now,
Yes, sir.
now this PR gap that I initially told you that it does this PR gap, for this PR gap, consider it as a switch. So generally what happens, if you use PR gap at a certain voltage level, the between these two sphere, air is there. So air, as you know that air has certain breakdown voltage. So if we do some triggering, then what will happen? There will be breakdown between these two sphere, and the path will be short circuited. That means it will act as a switch is closed. So the charge deposited in the capacitor will be discharged through this RE. Okay. So if we consider this base, and another thing is that if you see this waveform, this waveform is not a standard impulse voltage waveform, because we know that the impulse voltage has a certain front time, has a certain tail time. That means it will take some time to reach the peak, and it will have some time to settle or to go at a certain value. So shape is here, the shape is different. That means you have to design the circuit based on how is the characteristics of the impulse voltage. But this is not the standard impulse voltage, but here we have actually presented a basic circuit in order to produce a pulse actually. Is it clear?
Yes, sir.
Okay. So now if we look at this basic circuit, we can categorize, or we can divide this basic circuit into three different parts. We can say this one VDC, we can say it is a DC source or charging section, because as you know that we can't directly apply the DC source, because as you know our power is generally AC in nature. So somehow we have to make it a DC. So we can say it is a DC source or charging section. Okay. Now this one is the generation stage. Okay, how much voltage magnitude we want to get actually, that actually dependent on how you are configuring the circuit. That means if you are configuring a circuit, suppose in such a way that how the voltage, the magnitude of the voltage you are applying should be equal to the magnitude of the voltage that you are getting at the output side, then your configuration will be in one type. Suppose you want the double the voltage you are applying, then your circuit configuration will be in the another type. So how much output you want to get, based on that your generation stage or the section will be configured, and that will be discussed later. And the last one is the output stage. That is very important stage, because in this basic circuit, we have seen that if we only use a capacitor and a resistor, then there is a pulse, definitely there is a pulse, but the nature of the pulse is not like the standard impulse voltage that we have already studied in our course. So somehow you have to shape up the pulse. So for this purpose, you have to configure the circuit according to your pulse, say, configuration of the pulse, and that will be also be discussed in the next section. Okay, so let's start with the observation of the measure section. So first, what we told you, we said that there is a first section is the charging section or DC source. Generally, this is a DC charging stage, and this DC charging stage is generally controlled by a control panel, which is in our laboratory. There is a big control panel. So from this control panel, we generally control the DC charging stage. Okay. Now second one is the multiplier stage, that we have already discussed about the multiplier stage. Multiplier stage means what? Which stage? That means that stage actually decides how much magnitude voltage you want to get actually. That will be decided how you are configuring your multiplier stage. Okay, and this is your multiplier stage, and the last stage, this stage is the wave shaping stage. That means how you are going to shaping up the pulse voltage. That depends on your configuration of your circuit, and this is known as the wave shaping stage. And once you generate the impulse voltage, definitely you have to measure somehow, because otherwise how can you know the magnitude of the impulse voltage? Okay. So generally we use measuring sphere. So this is your measuring sphere. So based on using this measuring sphere, you can measure the impulse voltage. Okay. So let's go one by one. First one is the control room. We are going for the control room. Its control panel looks like that. Okay. So there are meters. Okay. These are the meters. Okay. This is a current control, this is voltage control, that is variac. Okay, and this is your triggering circuit. Okay, there is some on-off switch, and these two buttons are very important, because these two will increase or decrease the gap distance between the sphere. Okay, so, and if you go, the main component is that variac. Okay, that means variac, this is your variac. Okay, we can control the voltage using this variac. And using the push button, we can increase or decrease the distance. This push button increase, you can see increase, decrease. So we can increase or decrease the distance. And third one is the triggering, because you know there is a triggering required. Do you know why triggering is required? Do you understand the triggering circuit? Triggering. Have you studied the breakdown of gaseous insulation in your material course subject?
Yes.
So how breakdown of gaseous insulation occur? What is the process for breakdown of gaseous insulation? Anyone can tell me? Hello, Ravi Ranjan. Are you there, Ravi Ranjan?
Yes, sir.
So when your class supposed to be started?
At 2:30, sir, I was giving exam, sir.
Which exam?
Sir, it was campus placement exam, sir.
Then
Of 2 months.
you should not join in this class, na? Because you come late and just join now, then that is not actually desired.
Sorry, sir. Sir. From next class, I will write on time, sir.
Anyway, so what we are talking about?
The ionization, because the ionization.
Ionization. So what is the process of ionization of gases insulation?
The process is we apply the voltage in the electron.
No. That is different. So I'm just asking about process. There are two mechanisms behind the breakdown of this gases insulation. I think you know that very much.
Collision.
Collision theory is fine, but there is a particular name of these two mechanisms. One is avalanche mechanism, another one is streamer mechanism. Have you studied? Have you heard the term avalanche mechanism?
Yes.
So for starting of this avalanche mechanism, what you require? You can't start the avalanche mechanism unless you have a initial electron. Because how the electron will collide if you don't have any free electron? Because whenever you apply voltage, that electron start accelerating towards positive plate. Okay, and that electron will collide with a neutral molecule, and there is a energy transfer from electron to the neutral molecule. And if the energy becomes higher than the transfer energy becomes higher than the ionization energy of the molecules, then the neutral molecule will get ionized, and a new electron will be produced. These two new electrons will again produce another two new electrons, and the number of electrons will get multiplied by at each stage actually. And this process is known as avalanche mechanism. I think you know that. Have you studied it? Forgot. Good. So whenever you say breakdown of something, breakdown of gaseous insulation, you need an initiatory electron. We say, okay. And as you know that we are using pair gap as a switch. Okay, that means between this pair gap you have air, and air is nothing but a gaseous insulation. Okay, so in order to break down the gaseous insulation, you need an electron. So that electron is triggered by some other mechanism. So there is a triggering circuit, because as long as your initiatory electron is absent, how much voltage you increase, you will not get any breakdown voltage. That means no breakdown will be occur. If there is sometimes what happens, there are some initiatory electron present. Sometimes you have to provide electrons externally to start the process or to start the mechanism. Okay, so I am not discussing about too much about it, because if you are interested, you can go through it: avalanche process, avalanche mechanism, streamer mechanism, what is it, and how the breakdown is occurred during this avalanche mechanism and streamer mechanism. Okay, so you can start it if you are interested. So yeah, so we have already discussed about it. So there is a DC meter, there is a variac, there is a gap distance. We can increase the, if we push the positive, then the gap distance will increase. If we push the negative, then gap distance will decrease. And definitely there is a triggering circuit. And you can see this is a triggering circuit. This is a variac. So you can. I think you have seen the variac in your machine laboratory. Have you seen it, variac?
Yes, sir.
Okay, and
Yes,
it is assembled in our control panel. So you can't find it separately. So it has been assembled already. And there is a meter. So it is an analog meter. You can see how much magnitude your DC voltage is. And you can decrease the gap distance. And definitely this button is a triggering button. So if you push it, you will get the initiatory electron. Okay, is it clear? So now DC charging stage. Okay. So before going to so we have already discussed. So DC charging stage. So before going to the DC charging stage, we would like to discuss about how the voltage is doubled actually, or voltage doubler circuit. So I think you have some basic idea about the voltage doubler circuit. Have you studied the voltage doubler circuit in your high voltage course?
Yes, sir.
Okay. So if we start discussing about the voltage doubler circuit, so what happens? The basic circuit looks like that. Okay. So in this basic circuit, you have a voltage source, you have a capacitor, and you have two diodes, and there is another capacitor C2, and this is RL. So how this voltage is doubled? So now this cycle, when the negative half cycle of this supply voltage, during the negative half cycle of the supply voltage, generally this diode D2 start conducting. Okay, and the circuit actually current start flow this to D2, and it will start charging the capacitor C1 in this way. That means the right hand plate becomes positively charged, whereas the left hand plate becomes negatively charged. Okay, so if I consider the magnitude of this AC voltage source, or peak of this AC voltage source is Vm, so definitely the capacitor will be charged up to Vm. There is no doubt about it. Okay, now during the positive half cycle, that means during the positive half cycle, this D2 will not conduct, only D1 will conduct. That means if we go to the next figure, that means D2 will not conduct. That's why a cross sign is given besides D2, and D1 will start conducting. That means here negative, positive, negative, positive. So these two voltages will be added up, and you know the peak value of this voltage is Vm. So this capacitor will be charged up to twice Vm. Okay, so here you can see your peak value of the AC source is Vm, but here as an output you are getting 2 Vm. So you are doubling the peak value of your AC voltage source. That's why it is known as voltage doubler circuit. Is it clear to all? You have already studied in your third year course, so I think you can understand. Okay. So now we are going to our practical system. That means the impulse generator system. Okay. So you can see we have a 230 volt AC supply. Definitely, you know that is our standard voltage AC voltage supply, and we have used a very high voltage transformer. Okay, and its output is 82 kilovolt RMS. Now there is C and R. So if we go back to this C actually is the C1. Okay, so what will happen? This C1 will be charged up. Okay, and during negative half cycle, this C1 will be charged up. That means negative, positive. Now during the positive half cycle, that voltage output at the high voltage transformer will get added with the capacitive charge capacitive voltage, and that will start conducting through this diode D1, and that will go like that, and we will get the positive impulse voltage. Now you can ask me, then what is the utility of this D2? Suppose if you don't connect D1, and if it is connect here, and if you connect D2 here, then definitely during positive half cycle, that side will be positive, that side will be negative. Again during negative half cycle, okay, that side will be negative, that side will be positive. So positive, negative, positive, negative. That means the this diode will start conducting. That means the output you will get is the negative voltage. So what is your requirement? Either you want to get a positive impulse voltage, or you want to get negative impulse voltage. That actually depends which configuration you are using for generating the DC charging voltage. Okay, so this is this voltage actually is connected, or this portion is connected to the multiplier stage, and you can use a direct PMMC meter for measuring the how much is the magnitude of this DC charging voltage. Okay, and there is another thing you can see in this circuit. This is nothing but a iron rod. Okay, and this iron rod is connected to the AC supply. Okay, so what is the purpose of this using iron rod? Generally, when we start the impulse voltage, what happens? This supply voltage is here also here. So what happens? due to this supply voltage, there is the rod actually start go to the upward direction. Okay. Now once you switch off the supply, what happens? There is no power here, so this rod will automatically go down, and as you can see, the other end of this rod is connected to the ground. So when you switch off your impulse voltage, it's automatically get grounded in order to discharge if any charge remains in the capacitors. So it is for our safety purpose. We use a rod, okay, iron rod, okay. So is it clear up to now? Okay, and you can see the output of a HT transformer is 82 kV RMS, and the maximum output voltage DC voltage we get is equal to plus minus 175 kV DC. Plus minus means when we connect this diode, then we get plus 175 kV DC. If we connect this diode, then we get minus 175 kV DC. Okay. So what is the actual picture? So actual picture you can see, this is the diode, this is R, that means this R is this R, this is C, and this is the earthing resistance, and this portion is the this is high voltage transformer, and this portion is the earthing resistance. That means that is used for our safety purpose. Okay.
Yes, sir.
Now coming to the multiplier section. So generally, if you go the detailing of the circuit, the multiplier circuit actually looks like that. So before discussing about the multiplier circuit, let us take a section of this multiplier circuit. Okay. And the section of this multiplier circuit looks like that. Okay. So suppose this is a capacitor, there is a capacitor, there is a RCH. So we are taking this one, and there is another capacitor. Okay. There is another capacitor, and there is RCH, and suppose there is a switch between these two. Okay. And forget about this one. So only we will discuss this one. So when you are applying DC voltage, that means that will start charging this capacitor as well as this capacitor, because there will be charging current through this, So now, if the voltage or the capacitor will be charged up to VDC for this capacitor, and for this capacitor the charge will be VDC. So now if you look at this circuit, this is negative, positive, and somehow if it gets short circuited, then what will happen? This will be happen negative, positive. So what happens? We adjust the gap between the sphere in such a way that once the voltage reached of this capacitor up to VDC, then there will be short circuit. That means we trigger, and there is a short circuit between this sphere, and we will get the 2 VDC, because this VDC will be added to this VDC, and we will get the 2 VDC. Okay. So if you look at this circuit, these 4 capacitor, that means 1, 2, 3, 4. These 4 capacitor are connected in parallel. Again, 1, 2, 3, 4. These 4 capacitor again parallel. So when you apply 175 kV VDC, then definitely this capacitor will be charged at 175 kV. This capacitor will be charged at 175 kV. This will also be charged at 175 kV, and this will also be charged 175. Now tell me, what will be the output voltage of this 4 capacitor, of the combination of these 4 capacitor? They are connected in parallel. So what will be the output voltage? Sorry? 175, 175, 175, 175. So what will be the output voltage? শুনতে পাচ্ছি না। Hello?
175 to
175 kV.
Yes.
Similarly, if you consider this stage, here also this capacitor will be charged at 175. Here also voltage will be 175. Here also 175, 175. So here you will get the 175. Now look at the interesting thing. We have not connected this pair to this pair, this pair to. What we did, we actually we connected these two combination in series. That means 175 kV. So plus minus, this connected to the minus plus, because if you see, the upper plate of each capacitor is plus and the lower plate is minus. Here also the upper plate is plus and lower plate is minus. Now if you see this, the plus upper plate, suppose this is trigger and this is short circuited, it is connected to the negative plate of the capacitor of the next stage. So what will happen? This 175 kV will be added to this 175 kV in order to get 350 kV. Okay, and as we are doubling the voltage, so you can say it is a doubler circuit. But instead of doubling the circuit, you could have done 4 stage or 8 stage, because you could have done this capacitor, you can connect it series this capacitor with this capacitor and this capacitor again with this capacitor. So 175, we have used at a 2 stage. If we use 4 stage, then 175 into 4 stage 4, that will be equal to how much? 700 kV. Again, if we make it 8 stage, then what will be the magnitude of the voltage? It will be 1400 kV. So at the starting of our presentation, we showed you that the rating of our impulse generator is 1400 kV. Now you can understand how we can produce 1400 kV voltage using our impulse generator. Is it clear?
Yes, sir.
And the resistance which are connected here, actually what happens, if you use impulse generator, definitely there are some wires and there are some inductor. So definitely there will be some oscillation, and we don't want oscillation. So in order to damping out this oscillation, we use that resistance as every stages. Okay, so you can see these are some damping resistances. Okay, so that's all. So here we can find, so 175 kV is 175 kV, so 350 kV, 700 for 8 capacitor in series, we can get 1400 kV. Okay, so you can say this portion is this is the actual picture of the impulse generator. Okay, you can see this is the actual picture of the impulse generator. So this is the stage capacitor. That means this capacitor is this capacitor. Okay, this capacitor. This stage capacitor, we say it's stage capacitor. This is your charging resistor, and this is your discharging resistor. And this you can see there is a sphere, so there will be a sphere cap. Okay, and this is the main figure of this impulse generator. If you visit in our high voltage lab, you can see it. It is in the middle of our high voltage lab. Then you can see the impulse voltage.
So in practical scenario, where this type of impulse generator has been used?
Sorry.
So in real life things, I mean in power station or those type of things, where the impulse generator has been used?
Where the impulse generator has been used?
Yes, sir.
That will be discussed. That will be discussed.
Okay.
But as you have asked, I am telling you what happens when you install a transformer. Actually, transformer is an outdoor instrument, so you have to install it outdoor. So sometimes what happens, your transformer may get affected by lightning surge. Okay, so what happens, whether it can withstand the lightning impulse or not. So before installing the transformer, you have to check by applying the artificially lightning impulse, which is generated through this impulse voltage. So before installing, you need to check whether the transformer insulation is capable of withstanding that impulse voltage. Now, if you are sure that the transformer is capable of withstanding impulse voltage, then you can easily install that, and you know that if lightning strike on the transformer, there will be no problem, because we have enough insulation that can protect the transformer. Because you know that transformer is a very critical instrument in our power system, and its cost is very high. So somehow you have to protect the transformer. So in order to protect the transformer, you have to test that transformer using there are different tests, and among these tests, impulse test is one test actually. Another test which you need to do before installing. So is it clear now?
Yes, but sir, one thing that out of the context, but with the context of transformer, if the transformer is tested when it is it is made properly, or it has been tested in for the insulation only. I mean, if the transformer is made properly and then we test with a impulse generator, if it gets damaged, then that is not serving the purpose.
No. Then yes. Suppose you have tried to make it properly, and there may be some defect because you are using some machinery and you are using sometimes manual labor are involved. So if the transformer can't withstand that voltage, then definitely you can say there is some problem inside the insulation, and you have to check where is the problem. And if some weak point inside the insulation, so you have to check where is the weak point. Okay. Again, if you can identify this weak point, then you have to take some protection for removing that weak point actually.
Yes, sir.
Okay.
Okay.
So that's for the now coming to the wave shaping section. So I think you have studied in your impulse generator course in high voltage that in order to shaping up the wave, you need to use a charging resistors along with a charging voltage, a charging resistors, and a discharging resistance. Okay. So what happens? Here you are getting the output voltage, so the capacitor. Suppose you are getting here 350 kV this voltage. Okay. Now this will charge the capacitor CB. Okay. And there is a resistor and there is a capacitor. So it will not get instantly charged. The charging voltage, the voltage across the CB will increase. It's like an exponential because there is a R, and you know if there is a R and C circuit, the voltage nature becomes exponential. So, and what will be the slope of the exponential curve? That will depend on the value of RT and CB because it is a multiplication of RT and CB, and the nature will be like that. Now, once it is charged, so it will start get discharged, and the discharging will be through RT and RE. So a extra RE is added with the RT, and the RE value becomes much more higher than the RT, so that it gets discharged for a longer time in comparison with the charging time. Okay, so RE is known as the you can say it provides the discharge path, and RE value becomes much more higher than the RT, so the wave shapes looks like that. Is it clear? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes.
Okay. So you can see this is the actual figure of this. This is RE. So RE means this one. That means the discharging portion. This is CB, and I think RT is not shown here. So yeah. So there is also RT. Okay. So you can see this looks like that. Okay. This is the wave shaping portion. And coming to the measuring sphere, and you can see there is a measuring sphere. Okay. And whenever you are designing a measuring sphere, you can't take any diameter. That means your diameter should be fixed, or diameter should be decided according to some standard, some IEEE standard. You can follow any standard, IEEE standard, IEC standard, or IS standard. Do you know what is the full form of IEC? It is a standard. International Electrotechnical Commission, IEC. Similarly, in India, we have a standard, IS, Indian standard. Okay. So you have to follow the standard. Okay. So generally, sphere gap in our laboratory, we have sphere gap 25 centimeter. Besides that, there are sphere gap 6.25, 12.5, etc., etc. But we in our laboratory, we have 25 centimeter of diameter. Okay. So let's see how we can calibrate. Okay. So in order to, as I said that you can't take any diameter sphere. Okay. So you have to choose the diameter according to some standard. And in India, we follow IS 1876 in the year of 2005 for designing the measuring sphere. Okay. So according to that, if you use 25 centimeter diameter sphere, and if the gap distance between these two spheres is 1.4 centimeter, generally the breakdown voltage of air at STP, STP means standard temperature and pressure, is 42.9 kV for lightning impulse. Have you got my point? If you take 25 centimeter diameter sphere, and if the distance between the two sphere is 1.4 centimeter, then if you apply the voltage at STP or standard temperature and pressure, then the breakdown voltage of air is 42.9 kV peak, or kV peak at impulse voltage, if you apply the impulse voltage. Is it okay?
Yes, sir.
Now, so before going in details, further details for this measuring sphere, we need to know another thing. Okay, we need to know another term which is known as U50 or V50. Okay, then what happens? Before starting off our class, I asked you a question: how can we define switching lightning impulse voltage? And you told me that lightning impulse voltage can be defined by two parameters. One is front time, another one is tail time. And I asked you what is the value of front time and tail time of the switching lightning impulse voltage. You told me that the front time of the lightning impulse voltage is 1.2 microsecond and tail time is 50 microsecond. Okay. Now, so you have to somehow apply the voltage, and you have to generate this lightning impulse voltage. Otherwise, how can you test the transformer using the lightning voltage? And lightning impulse should be according to the standard. That means it will have 1.2 microsecond front time and 50 microsecond tail time. But it has been found out that if we look at the breakdown characteristics of a air under impulse voltage and time to breakdown, that means you are applying some voltage, impulse voltage, and you are just recording how much time is required for breaking down that air. It has been found out that if you apply 10 times voltage at 10 times, if the breakdown occur 5 times, then the curves you get actually resembles the characteristics of lightning impulse voltage. That means you are applying voltage 10 times. Okay, and among these 10 times, the breakdown is not occurring each time. So among the 10 times, the breakdown will occur 5 times. That means the probability of breakdown, because you know that as you have started the avalanche process, it is a probabilistic method. Okay, you don't know when the breakdown will occur. So if you are applying voltage, and if you see among the 10 times, if 5 times the breakdown has occurred, then you can say it is a 50% probability that breakdown will occur. And if you look at the characteristics of the 50% breakdown voltage, that actually you will get the peak value at 1.2 microsecond. Okay, and that actually resembles the actual characteristics of lightning impulse voltage. That's why we generally use the 50% breakdown voltage of this air. Is it clear to all? And it has not been calculated by any theoretical value. It is purely based on the experimental result. Actually, we have done so many experiments, and based on that result, we have found that if the probability is 50%, then we can say that the voltage or the impulse voltage we get actually indicate the impulse is actually the lightning impulse voltage. Is it clear? Yes or no? अरे है ना किसी तो बोल रहे हो बाकी ना क्या अच्छे ना चलेगा?
Yes, sir.
Yes, sir.
Now, if you generally what happens? So I have already mentioned that it is a probabilistic method. That means the breakdown will depends on the probability. Now, if we draw the probabilistic curve, that means you are applying voltage and you are looking, you are doing the experiment and you are looking how many times the actually breakdown occurring. So suppose you are applying the voltage 10 times, there might be possible that 1 times the breakdown has occurred, or 0 times the breakdown has occurred, or 3 times breakdown has occurred. So based on the gap distance, actually, because suppose you are applying voltage and your gap distance is something else, and based on your gap distance, your breakdown probability will also vary. So if you draw the probability of breakdown with the voltage, you will see the typical characteristics looks like that, and this curve is known as the S curve. Okay, just mind it. It looks like S. Okay, so it is an S curve. And if you look at the, because we need a V50, that means 50% probability. So if you look at the V50, that V50 actually lies at that region. Okay. And if you look at this region, if we go upward, this is a very V60. If we go downward, this is V40. And the range between V40 and V60 is the difference between V40 and V60 is very small. Okay. So that's why generally what we do, we generally take 40 to 60%, not exactly, as I said, it is a completely probabilistic method. So you cannot be assured that every time you will get 50% probability. So we take 40 to 61. That means if you apply 10 times voltage, then definitely that condition must be satisfied that among these 10 times, 4 to 6 times the breakdown will occur. Then we generally take that characteristics as a lightning impulse characteristics. And for that purpose, generally, if you started the lightning impulse voltage, you will see besides magnitude, you can say there is a tolerance limit, plus minus 3% tolerance limit. That actually indicates that your probability curve is not always 50%. That means your probability may vary from 40% to 60%. That's why a tolerance value actually comes in this scenario. So that's why you have to take the tolerance value of plus minus 3% with the magnitude. Is it clear? Okay?
Yes, sir.
যদি না বুঝতে পারে বলো, আমি আবার রিপিট করব, বা কোন জায়গাটা বুঝতে পারনি বলো, আমি আবার বলবো, কোনো অসুবিধা নেই। Okay, so hopefully you have understood. So now we have understood what is V50 and what is S curve, what is probabilistic curve. Now before starting that, we discussed about if we take 25 centimeter of diameter of sphere, okay, and if the gap between the two sphere is 1.4 centimeter, we know that the breakdown of air will occur at 42.9 kV. At which condition? The condition should be at STP. Okay. But when you are doing your experiments in laboratory, definitely STP means the pressure will be how much? At STP, the pressure is considered how much? Hello everyone. Hello. At STP, what is the value of pressure? সপ্তর্ষি মণ্ডল তুমি আছো?
Yes, sir.
প্রেসার ভ্যালু কত হয়?
10 to the power 5 pascals.
আমি যদি মিমি মার্কারিতে ধরি কত হয়?
760.
760. And temperature, how much is the temperature in centigrade?
298.
298. Okay. 25
Kelvin.
degrees centigrade or 298 Kelvin. Yeah. Okay. So that is the ST. But if you consider a laboratory condition when you are doing your experiment, your laboratory condition may not be always at STP condition. Your laboratory temperature may vary, and your pressure may also be different from your STP condition. So definitely you have to incorporate some factor in order to correct that value. Okay, because that factor will depend how much is the temperature deviate from the STP condition and how much is the pressure has deviated from STP condition. Okay. So a correction factor needs to be introduced during your calculation. Okay. And IS 1876 actually suggests the procedure for such correction. Okay. So these are the correction. Suppose U0 value is the U0, you are getting the breakdown voltage of air at STP condition, and U is the actual condition, the breakdown voltage at laboratory condition. Then what is the relation between U0 and U? U0 will be equal to U divided by delta into K. This delta is nothing but the air density correction factor. Okay, this delta can be calculated P by B0, where is the B is the barometric pressure during laboratory condition, B0 is the barometric pressure at STP, 273 plus T0. T0 is the standard temperature, to sometimes we use 22 centigrade, and T is the what I can say, laboratory temperature. And there is another one is the K. K is the, sometimes it is called humidity correction factor K, that can be calculated 1 plus 0.002 into H. H is nothing but the relative humidity, that we will study what is relative humidity, divided by delta. Delta we have already calculated, minus 8.5. Okay. So once you can calculate the value of K and delta, then if you know the value of U, so U0, so from here you can calculate the breakdown voltage of air at laboratory condition. Okay, is it okay? So this is your thermometer through which we can measure the temperature. There are two thermometers. One is dry bulb, another one is wet bulb. There is dry bulb. In wet bulb, we use water below the thermometer. Okay, and we have seen that generally the dry thermometer, the temperature difference between dry thermometer and wet thermometer is nearly 2 degrees centigrade. Okay. And this is your barometer. You can see if you enter to our lab, at the entrance you will see the barometer as well as these two thermometers. Okay. Who is there? Yeah. So correction factor. So that correction factor of we can get according to IS 731, because we have already mentioned that we need to calculate H. Okay, so that can be obtained by from another IS, which is known as IS 731. Okay, so this is IS 731. So in this IS 731, there is a graph. In this axis, you can see the dry temperature. Okay, and these perpendicular lines actually indicates the dry temperature, and these lines are indicate the wet temperature. So if you know the dry temperature, if you know the wet temperature, then from here you can, from this graph, you can calculate the absolute humidity or H. Okay. Now once you get H, so from here you can, once you get H, now you can easily calculate delta from the dry temperature. So you know the value of H, you know the value of delta. From this equation, you can calculate the value of K. So once you know the value of K and delta, you can calculate the breakdown voltage at laboratory condition. Okay. So we have taken an example, typical example, in order to understand that. So for a sphere diameter of 20 centimeter and gap distance of 1.4 centimeter, IS 1876 suggested that U50 value of is 42.9 kV. U50 means the 50% probability that has been indicated by U50. So at the lab, dry bulb temperature is 24 degree, wet temperature is 22 degree, and barometric pressure is 761 millimeter. Okay. So if you go to the equation 3, this is your equation 3. From this equation 3, you know the T0 value, you know the T. T means here, T is nothing but 24 degrees centigrade. So from there, from equation 3, you can easily calculate the value of delta. Okay. And again, from 731, you can calculate the value of H. So from there, from equation 2, you can calculate the value of K. So now put multiply 42.9 with this K and the value of delta. From that, you can get the breakdown voltage of air at laboratory condition, that is 43.2. At STP, it was 42.9, but at laboratory condition, you are getting 43.2 kVp. Okay. And based on that, you can calibrate. That means laboratory condition, you know, for that particular sphere diameter and particular gap setting, your breakdown voltage will be 43.2 kVp, not 42.9 kVp. Is it clear? Okay. So we have summarized the procedure. So take dry and wet bulb reading and barometer pressure in the lab. So from IS 1876 for a given sphere diameter of 25 centimeters and gap setting of 1.4 centimeter, find out the U50 value. Okay, so 40 and apply correction factor. So you will get 43.2 kVp. That we have already discussed. And procedure, so that have already been discussed. So adjust the variac, say 25 kV, read the reading. Okay, and if it is required, just change the gap distance. Okay, adjust and read, that already been discussed. Okay, so and another thing is that whenever you are go to this circuit, so whenever you are doubling the voltage, that means you have here one sphere gap and there is another sphere gap, because your multiplication stage has been over. Now you are applying the voltage to the wave shape. So there is a switch, there is a requirement of the switch. So you have one sphere gap, there is another sphere gap. So you have to be sure that these two spheres actually spark at the same time. Otherwise, suppose there is a breakdown between these two spheres and there is no spark between these two spheres, then what will happen? You will not get the output voltage. So you have to make sure the breakdown occurs between these two sphere gaps as simultaneously. Okay, then you will get the impulse voltage. So that has been explained. So you have to adjust the voltage by having the variac, and you have to push the trigger. So observe the spark. So you can see here, you can see the spark. Okay. So procedure, press 10 times the same voltage. Observe the measuring sphere spark should be fire 4 to 6 times. Okay. If the measuring sphere fire less, then you have to increase the DC voltage a little bit more and fire 10 times. If the measuring sphere fires more, you have to decrease the DC voltage a little and fire 10 times again. Okay. So, and now you have to calibrate the DC to impulse, because you know the DC magnitude, because you know at standard at laboratory condition, if we take the 25 centimeter diameter sphere and if we make a gap distance of 1.4 centimeter, then at laboratory condition our breakdown voltage of air is suppose 43.2 kVp. Now suppose we want some other value. Suppose we want 50 kVp for some other purpose. Okay. So how can we calibrate? Generally, what is the actual procedure? You have to install some measuring instrument. But we don't have some measuring instrument. So what we do, we generally calibrate it. That means for using unitary method, for 25 kV DC, the impulse voltage is 43.2 kV peak. For 50 kV peak impulse voltage, what will be your charging voltage? Okay. So based on that calculation, we generally set the value. Yes, you can say me that there may be some error. Definitely there has some error. But it is our limitation, you can say. So we use this process for calibrating the impulse voltage. Okay. This is your observation, sir. And someone asked me why impulse generator is needed actually. So there is, you can say high voltage equipment installed in power system network. So may face direct and indirect lightning strike during their service life. So before commissioning, high voltage equipment is tested for their lighting impulse withstand capability. Okay. So that's all if you have any question, you can ask me. If you have not understood at any point, then you can ask me. Is it clear? Okay, so
Yes, sir.
let me try. We have a video, so let's see how actually, because you are not able to physically do the. Are you seeing it?
Yes, sir.
Okay. This is your iron rod actually for protection purpose. This is your impulse voltage. This is a measuring sphere, you can see. We are increasing the voltage, triggering. So that's all. So you can see. So yeah. Now you can ask any question if you have. So hopefully you don't have any question. So I am opening an instruction impulse. So for your, I think you can, how you will prepare the report. So we have prepared an instruction sheet. So your front page will be like that. Name, email ID, contact number, class, and first of all you write an objective of the experiments. Then keep apparatus table. What are the apparatus we are using? Okay. And then draw the circuit diagram. Okay, and this circuit diagram, now again find the, we have already discussed how you can calculate the delta and k. So using this procedure you can calculate the delta and k, and this is your IS 1876. So the recurrent voltage of air at standard test, and from IS 731 you can calculate the value of H. Okay, this is your curve, and based on that you can calculate the value of U. So this is a 50%. So calculate. This I will share with you. Okay. Now tell me, is it fine or not? Okay. Another thing is that so you have to submit your report. So I think today is 6th of September. So you have to submit your report on within 13th of September. Is it okay? Okay. So if anyone does not submit your report within 13th, so your marks will be deducted. Okay. So let's take your attendance. So today is 6/9. Rupoi Tudu, are you there?
Yes, sir.
Priyansu, are you there?
Yes, sir.
Pratul,
Yes, sir.
Ashish, Shubhadeep,
Present, sir.
Paras,
Yes, sir.
Shubhamoy,
Sir, Ashish 1108, sir.
কোথায় ছিলে বাবা? পালিয়ে গেছিলে নাকি? Anyway, Soham,
Sir, I was there, sir. 1123.
yeah, Soham, I have given your attendance.
Sir, Shom exam দিছে, এক্সামের বললো না?
Also, Soham exam. Rahul,
Present, sir.
Prabhupta,
Prabhuda, yes, sir. Present 112.
Sugata,
Yes, sir. Please.
Orko,
Yes, sir.
Saptoshi,
Yes, sir.
Soumodip,
Yes, sir.
Deepan,
Yes, sir.
Yas,
Yes, sir.
Shobik,
Present, sir.
Rohit, জয়ন্ত,
Yes, sir.
আরিয়ান,
Yes, sir.
অঙ্কিত,
Yes, sir.
অনির্বাণ,
Present, sir.
সুমন্ত,
Present, sir.
অঙ্কেশ নেই, রবিরঞ্জন, পরেশ, পরেশ, পবন,
Yes, sir. Present, sir.
পবন কুমার বারনওয়াল, এক্সাম গুড, সুব্রজিৎ,
Yes, sir.
সিঞ্জন,
Yes, sir.
স্পন্দন,
Yes, sir.
ফাইজান, ফাইজান,
Sir, he has written in chat box.
sorry, okay, no problem, I have seen he joined in okay, no.
Sir, যারা যারা এক্সাম দিচ্ছে তাদেরকে মেল করতে বলবো আপনাকে?
মেল করতে পারো বা তোমাদের যে সিআর সে আমাকে একটা লিস্ট পাঠিয়ে দিতে পারবে।
স্যার এখানে যে তিনজন ছিল ওই তিনজনই, মানে
এই তিনজন, তাই তো?
হ্যাঁ, যে তিনজন আপনি
ঠিক আছে, তো ওদের প্রসিডিওর কি আমি তো একটু জেনে নিই, কারণ ওদের মনে হয়, আমার মনে হয় যিনি ল্যাবে যিনি আছেন দায়িত্ব, ওনার কাছ থেকে একটা কিছু লেটার ফেটার ইস্যু করতে হবে, আদারওয়াইজ তো আমি অ্যালাউ করতে পারবো না। তো সেটা ওদেরকে একটু বলবে একটু জেনে নিতে, তা আমি আমার তরফ থেকে জানবো, বাট ওদেরও বলবে একটু জেনে নিতে প্রসিডিওরটা কি, মানে ওদের যে এরিয়ার হবে কি হবে না, কি ব্যাপারটা কি সেটা একটু জেনে নিতে, সেই অনুযায়ী আমরা এগোবো। ওদের একটু জেনে নিতে বলবে।
স্যার এমনি আগের ইয়ার থেকে স্যার, আমাদের আগের ইয়ারে স্যার মানে আপনার যদি অন্য কোনো এই একই ল্যাব যদি অন্য কোনো সেকশনে বা এতে থাকে ক্লাস,
না আমার শুধু তোমাদের সেকশনে আছে, সেটা তুমি দেখো অন্য টিচাররা হয়তো আছে, কারণ তোমাদের B2 আছে বা A1 A2 আছে, তো সেটাই বলছি। এবার ওরা যদি ম্যাডামের সঙ্গে, আমার মনে হয় সুপর্ণা ম্যাডাম হচ্ছেন মনে ইনচার্জে আছেন, ওনার সঙ্গে যদি কথা বলে এবং উনি যদি অ্যারেঞ্জ করে দেন তাহলে কোনো সমস্যা নেই।
ওকে স্যার, ওকে,
ওদেরকে কথা বলতে বলো, সেই জন্যই বললাম ওদেরকে কথা বলতে।
ওকে স্যার, ওকে, থ্যাংক ইউ।
আর তোমরা কিন্তু 13 তারিখের মধ্যে আমাকে রিপোর্ট জমা দেবে, ঠিক আছে? আমি তোমাদের ওইটা ইনস্ট্রাকশনটা পাঠিয়ে দিচ্ছি যাতে তোমাদের সুবিধা হয়, ঠিক আছে? না, ওরা যেহেতু এক্সপেরিমেন্ট করেনি, ওরা কেন জমা দেবে? ওরা তো জমা দিতে পারবে না, ওরা তো এক্সপেরিমেন্ট করেনি কিছু, ঠিক আছে? হ্যাঁ, কথা বলে নাও, চেক করে নাও, ঠিক আছে? সেটা সুবিধা, ঠিক আছে? ওকে, সো ইউ মে লিভ নাও।